More than 250 experts in the traffic signals industry joined together in person to hear a range of papers here in Nottingham. These recordings are brought to you by AGD Systems, Colas, SRL Traffic Systems, Smart Video and Sensing, Vivacity and Yunex Traffic.
Thanks very much. Never had to do too many bios before. It goes on, doesn't it? But I'm here. It's my first JCT conference, and it's really great to be here, actually. My last time I presented Fusion was at Siemens User Groups back in 2019, and I think it's about time we sort of give an update of sort of where we are. We've had very much, back then was, what are we going to do? And today can be, what have we done? With a sneak peek, obviously. A sneak peek of where we're sort of going as well. So today, hope to sort of start off with where are we with some of the trials in London, and then I'll look at sort of 5 key points about Fusion, some of the problems that there are, and then how we've tried to solve them. Doesn't mean we have all the answers, but I can give you a flavor of how we've attempted the problem. You'll see some results, and then we'll, again, go towards the future. So let's see how this goes. So TfL and Yunex are jointly collaborating and developing Fusion, RTO and Fusion. And we went live in London in a region, Wandsworth, and for 2 sites, which was a Scoot region, and we migrated them from Scoot into Fusion Control. And that's been running since sort of November 2020, on and off, not continuously, but it's been absolutely amazing for us to get some real feedback into the system to validate what Fusion is doing. And we get some real feedback from TfL about the user interface, how Fusion's performing, and the sites are then closely monitored, and we can get that sort of valuable feedback to us. Now, we've got lots of expansions planned. Obviously, as more and more features come into Fusion, we'll roll it out in more and more areas. And we'll talk a little bit, like product launch is not until Q2 of next year, so this is why we're going through the trial stage at the moment, but we're continuously developing the product at the moment. And I'll show you a video, and I would say for most people, I'm going to show you a video of some traffic lights. That may not be the most exciting, but for this audience, I'm hoping that you will enjoy it. It's it's just a GIF, so it'll continuously loop over. And what you'll see is, you'll see a prototype version of the Fusion UI to help monitor what's happening on the links. I'll use some language that will be familiar definitely for Scoot users. So this is one of the Fusion links that you can see on the left-hand side of the screen, and then you'll see the traffic running in the Wandsworth region in London. So some of the things to just point out here, just to give you guys a flavor of how we've been approaching it. So we also are looking at vertical queue lengths within Fusion in a similar way to a lot of the traditional systems out there. What this graphic actually shows is as objects, as cars travel over the detector, and we're actually representing all of it. So there's a 16-second delay from the car driving over the loop until it arrives at the stop line. So when you're sort of, for those really keen eyes amongst you, you'll sort of see where you're like, is there really 5 cars there? But this graphic's actually just amalgamating the 2 together. So you'll see stop line queues and everything over the detector. We are releasing the upgrade of this next month into the Living Labs. We'll be able to see slightly different UI. But again, I just want to give you guys a flavor because you haven't necessarily seen some of the screens of Fusion, just so you can get an idea of what's really going on here. You also see, like, for every link, we maintain like an arrival profile. So we have more data than this, but it's just to sort of say, here's a 10-minute snapshot of what the sort of flow has been at these links. So hopefully that's looped over once or twice now. You get an idea that Fusion's in control. You can see when the links are red, you can see when the links are green in here, and we'll have, shall we say, a little bit more well-rounded UI in the not-too-distant future in there, but this is what was happening in the Living Lab. So, somewhat salesy slide, which is not my style, but what you will hopefully get a flavor of is here are the sort of 5 things I want to run through the rest of the presentation this morning. Talking about optimization of all road users. This is not designed around the car. This is designed for all modes of transport. and I'll go into a little bit more detail in a minute. It's highly configurable, and we want to ease any of the configuration effort that goes in. We appreciate there's some challenges with the current sort of systems that are out there, so we've wanted to make this easier, more streamlined, a little bit more intuitive than what is already present. We want to talk about how we're increasing the safety and looking at CITS use cases within Fusion. We want to talk about the scale, that this isn't just for the Londons of the world, sorry TfL, this is also for other customers out there as well. And the headline figure, which we'll talk a little bit more about, is sort of reducing delays by up to 25% over conventional traffic control systems. And I'm sure this audience especially will want to know a little bit more detail there, so we'll get to that as we go through the presentation. Okay, so I said Fusion's not been designed around the car. Obviously, traffic signals play a big part in managing those conflicts, and we want to give a little bit more control to the cities about what's your policy. Is it people movement? Is it pedestrians crossing? Is it for buses that you want to give some form of priority to them? And we want to model each of the road users within Fusion more appropriately. So we have a concept where you can change your policy very easily through the different slider sort of techniques. We can say that a bicycle is more important to me than a car, where a bus is more important than an HGV, and we can sort of start breaking this down. Now, we are at the moment using the sort of traditional loop technology, so you don't have to upgrade and put new sensors across the network when you're using Fusion, but it's been designed so that when people that do have the richer data sensors, that we can feed that into Fusion and we can model the different modes that you'll have available. So at the moment in London, it's using traditional scoot loops. We also are using things like RTIG technology to get bus data into Fusion, so we can look at modeling the buses going through and give them the appropriate optimization or prioritization, depending on what you're aiming for. And I think one of the key differences here, compared to the likes of, shall we say, Scoot, would be that we're actually modeling it as a whole region. And that's not to say Scoot doesn't consider a region, for example, but this is actually a connected region. When you make a change at junction A, there's a knock-on effect in junction B, and so on. And where some of the traditional approaches don't really look at the consequence, it's over time you see the impact knocking on. Fusion is modeling and adapting and looking at how it impacts the downstream as well. So that's where we're looking at it as a whole region, and that's what we're talking about. It's a mesoscopic simulation that's going on. Every time an adaptation is made, we forecast what's going to happen, and then we make our adaptations accordingly. I think I've said all the points that are there. I'm not one for reading the slides too much, forgive me. So I'll move on to the next one. So another GIF for you, just to give you a flavor of the configuration page in Fusion. And what you're going to see is, someone changing in the top right-hand corner, sort of swapping between what we call configuration profiles. And a lot of the terms along the sort of tab side will be quite familiar to the likes of a Scoot user. We've got nodes, we've got links, we've got detectors. We're building on the well-known and understood terminology within the industry. But with config profiles, this is how we're moving away from a command-driven structure, where Scoot was some complicated commands sometimes, or you might not remember, is that a node-based command or a link-based command? What was the right SCN? And just starting to go away from that kind of command nature where you had to have lots of casts throughout your UTC system. We're trying to simplify this and have what we call configuration profiles. So you can easily have your base level configuration. With the click of a button, you're in your next profile. So if you're preparing a morning rush hour profile, or for preparing for an incident on like a northbound traffic or something like that, you can easily swap, make your changes. You can see in the UI that something has changed and it's been updated. And yeah, this is kind of how we're moving away from casts, basically, and going towards something that's a little bit more visual, a little bit more, hopefully, easy to understand. Lots of smiling faces, hopefully, but yeah, we're making a little bit of a difference in how the traditional approach was. Building on that slightly, We have also sort of the draft profile concept. So this is where you can make offline changes. So you could have Fusion running for a region and you want to add something in. No longer are you going to be tearing down the system to do an update or something in that style. You're going to be able to make your offline changes, batch them together if you want to, and when you're ready, you can commit them into the system, and Fusion will handle that transition. So if you've changed the plan structure, if you've added a stage in, added a link in, you need to do a different association, you'll be able to do that, and Fusion will transition from one to the other so as you commit your changes. So hopefully that, I think that gift's probably played through now as well. So hopefully you get the idea that that's looking at the sort of, being able to make changes offline and commit them into the live environment to, again, hopefully make that a little bit smoother. So a hot topic yesterday, so I'll keep this relatively brief. One of the things that we've been doing within Fusion, we're very much looking at CITS use cases, and we're looking at how we can send out SPAT data. We have a project in Belgium, and I think what Yunex was presenting yesterday, talking about your ITF files in GLOSA, could be in a similar space to where they are working as well. And we are trying to send out SPAT data from Fusion. And the way we're approaching that, because this is a real oxymoron, right? You want a reactive system to tell you exactly what you're going to do for the next however many seconds. And this is a real conflict of what, the adaptive nature of Fusion is trying to do. So we are introducing a rolling horizon. Now, this isn't in the product today, but it's going out for product launch, where we're trying to have a horizon where you can sort of guarantee that this will not change unless something important enough to the user has come in. So if a bus comes in, then you can actually say, I'm changing the SPAT data that I'm sending out, and here's the reason codes. And I think some of the projects in Central Europe, or we've got the Netherlands and Belgium working towards this sort of SPAT-M message, and actually giving the reason and justification of why you've changed the traffic lights. And this is where we're working towards within Fusion. So yeah, it's quite an exciting project for us that we're working towards. So this is going to be my bad joke. Forgive me for this. So we're saying Fusion is designed to scale for any size of network. So I thought I would say from London, the biggest city in the UK, to St. David's, which probably a lot of people know is the smallest city in the UK. Then done a little bit more digging, realized St. David's doesn't have any traffic lights. So that's maybe not the best example here. So the point being that obviously we're scaling Fusion, and that's behind the scenes. We don't want this to be for the user to worry about and say, oh, do I need a multi-computer setup? How many things do I need to deploy to make sure this supports as many regions as I've got? Fusion will scale as it needs to behind the scenes. It can be hosted and it can be deployed on-prem. It depends what people want. And so if you've got a cloud-based solution, it can scale automatically. Obviously, if it is on-premise, then it will be limited by the hardware that you've got available to you. But that's fine, and Fusion will be able to work for the size of customer that we have. Works alongside the multi-computer setup when you do need to scale because you've got large number of junctions in UTC, but that's the idea. And I got some laughs, so it wasn't too bad a joke, maybe. Okay, so looking at how we're reducing delays. Now, I would love to have showed you today, but hopefully that will be the next presentation of where we're seeing all the benefits on street. What I'm showing you today is a validated simulation model. Now, we've worked with TfL from day one on this. They obviously have a large amount of validated models where Scoot is finely tuned, Vism is finely tuned, and we get to see how Scoot is performing, and then we can benchmark against Scoot. We've had these models from the start, and this has always been what we're comparing Fusion against. And we also have the fixed time plans that TfL are actively using in the network today. So this isn't something where Scoot was configured years ago and it's perhaps drifted from where it could be. This is them actively using it, and we're able to compare against that. And this has been an invaluable tool for development to see, have we broken anything? Is it working the way we'd expect? And how is it actually performing? And equally, where is it not performing? And I think that's always valuable to get that feedback quickly during the development process. So one of the models that we use is place Green Man. I think it's in the A12 in London. And this is a 7-node region, and there's very close neighboring regions with pedestrians nearby. There's a little bit of data there about sort of the expected flows, but generally there's quite a lot of heavy traffic coming from the north-east onto the roundabout, going around the circular. There's some traffic coming off from the slip road and a little bit coming from the south. So quite often this is congested, it's double cycling, and we wanted to see how Fusion could perform it. And you can see a little bit, I know there's a lot of information here, apologies. In the bottom left-hand side, you can sort of see we've used this concept of link weights, which you already saw in some of the earlier slides. So where we say these routes are particularly important to us, then Fusion will give greater weight to keeping the traffic, moving on these. So we want to keep circulating traffic flowing, and that was how we set it up. And again, give a little bit of reassurance towards what is Fusion trying to do. This isn't a black box. This is familiar concepts to the traffic industry. We have cycle time optimizer. We have an offset optimizer. We have a split optimizer. We have what we call demand-dependent stage reallocation optimization. So when the demand-dependent stage isn't needed, we're looking to reuse that time a bit more appropriately rather than just giving it to the alternate stage. And we're actively trying these in London and obviously in simulation. And all things are configurable as you'd expect, and sort of what's the max step change you're allowed to make. And we're going along, I think I've still got a little bit of time, I'll wrap up quickly, where we're making 1-second step changes. So what we were saying is we've done thousands of simulations, and I just wanted to give you a bit of a flavor. So in some scenarios, we are seeing great benefits where Fusion is considerably outperforming Scoot. We have areas where the reallocation feature is making a big difference. One of the key things in this roundabout, there's masking detectors, and where we're not getting the great data from the loop, Fusion is able to model the traffic flowing through the roundabout a little bit more efficiently than what Scoot is doing. So we're getting a better representation of the demand in the model. So this is some of the areas where Fusion's really outperforming and therefore giving more appropriate green time to the various stages. I really should hurry up, apologies. I could talk on this all day. So a little bit of a flavor. As say, Fusion will be launched to the market in Q2 next year. We're continuing to trial with London. We're looking for more opportunities to try Fusion, not just in the UK, but abroad as well. And we have quite the roadmap. This isn't going to be it. It's not going to be just launched and that's it. There's more things we want to do. CITS is important for us. We are integrating more AI features into it, making sure we have appropriate traffic pattern recognition, and we want to continuously improve the UI, unsurprisingly. An important one I will mention is the automated validation. This is a project we're actively working on to use floating car data to help reduce the time the traffic engineer needs to be on street to validate and make sure that the Fusion's operating as expected. And again, we want to see this come to the market as soon as possible. So that's it from me. I'll leave that up as the final slide. Sorry for overrunning.
No, that's absolutely fine. Hands up if you want to ask a question. Lucy and Sam will bring the microphone to you. Just quickly, Andy, an observation more than a question. You kind of just happen to throw away remark, oh yeah, and it cuts emissions by 27%. I think I'm certainly not to somebody from Yunex because you keep winning the contracts, DIS, clean air zones, but this is significant, the amount of things that our industry are doing at the moment to just make things more efficient, and through making it efficient, improve the environment. Are you finding when you're talking to clients that that is the focus? It's what percentage, how are we doing on emissions and stuff?
Emissions, delay, we want to see promote active travel. We want to see pedestrians getting recognised and considered in the optimisation. You don't want them waiting in the dirty air. So yeah, absolutely emissions is key, but also getting that active travel element into Fusion and trying to represent it in the right way. And I think as well, some of the things we didn't say, this isn't just isolated. We can respond to the filters that are out there. So if you've got sensors on the street, we can integrate with strategy managers and change how we want to run, like have sort of active traffic management strategies in play to be able to help even more when the situation is particularly bad.
Excellent. Right, any questions? There's Simon at the front here.
I've got my own microphone. So, Simon Notley, DINIC. Really interesting presentation. Thank you. It's exciting to see so much suddenly happening in the world of UTC after a few decades of incremental changes. One thing you said right at the beginning kind of triggered me, because early in my career I did a lot of work with Highways England, and one of the things we spent a lot of time discussing and looking at was motorway shockwaves. Motorway shockwaves would not exist was it not for the fact that queues are not vertical stacks of vehicles, they're horizontal lines of vehicles. So why are we still modelling queues as vertical stacks?
Yeah, it's a great question, and we are trying to move away from that, but when you've got, I want to say garbage in, garbage out philosophy. When you've got loop data is your only source of data, that's not a wonderful representation of how objects are traveling through your region, how cars, buses, whatever they may be. So we have incorporated for how you validate a sort of vertical stop line model, as is well known within the industry. It's sort of tried and tested, and then you can have objects as they get closer. But when we're making our optimizations, things are not vertical queues, as you say. They have a spatial element as well, and we represent it when we're making adaptations and optimizations. But for the validation steps, we are still displaying it as a sort of vertical queue.
Thank you. And here?
Thanks. Robert from Edinburgh Council. The 25%, is there a particular aspect or weakness or way Scoot works that this is kind of picking up for that 25%? Or conversely, are there certain types of staging and junction layouts that figure is particularly applicable to?
Absolutely, and I'm not standing here to say it'll be 25% improvement in every scenario. I think let's be realistic there. I think some of the areas I just briefly touched on was like masking created a bit of a problem for Scoot, so it was really underrepresenting its queues and perhaps wasn't getting a chance to give the appropriate green time. And I think that's where we're having the connected model. We're able to see the upstream traffic flowing through the regions. We're able to represent the demand a little bit better. And I'd say there are some differences as well of how we're trying to approach it for the demand-dependent stage reallocation. When the stage isn't needed, there's no pedestrians, there's no side road, whatever, we're trying to use that green time that we're allocating up front and then saying, oh, that didn't come in, that wasn't needed, therefore we'll give it to the next stage or use it as the alternate stage, the preceding stage, whatever it might be, just to try and get a little bit more use out of it. And I think that's, again, a difference to how Scoot's trying to optimize. So I think that's some of the key areas that where we were seeing those gains. But we try it on a number of models, so it's not just Greenman, but I wanted to show something today.
Excellent. We're out of time, unfortunately, on the questions, but Yunex have a huge stand outside. Go and grab Andy during the coffee or lunch today. Plenty of time to talk to him. But for now, everyone, Andy Hamilton, thank you.
Thanks.